Good afternoon, everyone. For those of you who I might not have had a chance to meet yet, my name is Sandra Magnus. I'm the new Executive Director of the AIAA, and hopefully I'll be able to spend some time with you during this week. I just started 2.5 months ago, and I'm really excited to be here. You know, the AIAA has a long-standing reputation of being the aerospace professional society, and it was an organization I'm glad to be affiliated with, and we have a great future. We live in a very fast-paced time, changing time. We have some challenges ahead of us. There was a lot of discussion about how to stay relevant, and I think one of the most important things you do when you are faced with a dynamic environment like this is you go back to your roots and you remember your why as your touchstone. And I think the why for the AIAA is the fact that this is an organization that ignites the energy and celebrates the capabilities of the aerospace industry. At events like this, where in the meetings, you see the technical exchange as we gather to explore what we're doing in the technical areas and explore ideas. We're recognizing the accomplishments of the members of our profession, and we are generating interest with the next generation to come up and follow behind us and identifying the problems of the future. These are the things that we've always been about. These are the things we're going to be continuing to be about. And one thing I love about the aerospace community is we are a can-do group of people. There is no problem too difficult for us to take on and find a solution to. And we're going to grow in this new event model. You're going to see when you come to the meeting next year, you'll see all these aspects still embraced and propagated. We're a passionate group of people, and we will make things happen. And we know that we are vital to the evolution of our country, to the technology that we provide and the service we provide for our country, and we're going to continue to do that. And I think you'll hear a little bit about that today as we discuss in this New Horizons forum. We hear from Lieutenant General Larry James. Before we get started, though, I would like to thank our sponsors. Lockheed Martin, of course, is the premier conference sponsor, and they have sponsored the Duran Lecture, which those of you who attended that before this event had an opportunity to listen to. And then on Wednesday, the Von Karman Lectureship in Astronautics. That's going to be here Wednesday at 5:30, and we'll have Jim Crocker, the VP and General Manager of Lockheed Martin Space Systems, talking about From Galileo to Hubble, Mankind's Extraordinary Journey. So please come back here at 17:30 on Wednesday to hear that lecture. I'd also like to thank Boeing as one of our sponsorships of the Young Professionals Program, the Rising Leaders in Aerospace Forum, which are a series of meetings that are going on in parallel with our young professionals. Finally, I'd like to thank the SI organization for their sponsoring of the Cyber Cafe. With sponsors like these, we are able to continue to bring wonderful programming to our already pretty spectacular conferences. I'd like to take this moment to introduce to you Dr. John Evans, who is the Executive Chair, standing in for Executive Chair Ray Johnson. You'll see Dr. Evans around this week and providing some speaking opportunities and also getting out to meet every one of you. Dr. John Evans is the Corporate Vice President of International in Corporate Engineering and Technology, a brand new title for him. I was just informed. I had to say that. He's been at Lockheed. And a little bit about what he's doing at Lockheed. He ensures the global access to cutting-edge technology and enabling the corporation to rapidly develop new capabilities and open new markets. As the corporation technical ambassador, Dr. Evans develops and enhances relationships with governments, universities, and businesses globally to promote sales, ensure access to technology, and meet industrial participation commitments and promote economic development. Prior to joining Lockheed Martin, Dr. Evans was at DARPA as a program manager, leading initiatives in the fields of space communications, microtech, and nuclear energy. He's also held positions as Chief Technical Officer for the West Coast venture-funded startup Microfabrica and led MEMS scientists for Becton Dickinson, an energy consultant for the U.S. Congress Office of Technology Assessment. He was born in Minneapolis, Minnesota, and earned a BA degree in physics from Carleton College and an MS in civil engineering and a PhD in mechanical engineering from Berkeley and an MBA from Duke, so he comes very well credentialed. And Dr. Evans, if you please, takes a stand and introduce Tom.
Thank you, Sandy. Thank you, Sandy. It's a pleasure to be here today representing Lockheed Martin as a sponsor for this activity. And as such, it's my privilege to introduce the chair of the New Horizons Forum, Tom Sheridan. Tom Sheridan is the Vice President for National Security Space at the SI organization. In this role, he's responsible for providing systems engineering and integration services to customers in the intelligence community, the military, and NASA in support of national security objectives. Tom has over 35 years of government and military experience in space-related acquisitions, operations, and requirements development. Prior to this current position, Tom was commander of the Air Force's Space and Missile Systems Center, as well as the Air Force Program Executive Officer for Space. In this dual role, he managed an annual budget of over $10 billion, overseeing the research, design, development, acquisition, launch, and sustainment of the Air Force's space launch systems. Tom also previously served as a deputy director of the National Reconnaissance Office, where he designed, developed, delivered space systems in support of our national security objectives. Tom also served as a director of requirements at the Air Force Space and Systems Command, where he led a team of government personnel and contractors to develop and publish requirements for all Air Force space and missile systems. Tom attended the University of Connecticut, where he received a bachelor's degree in mechanical engineering and completed the Air Force's ROTC program. As a distinguished graduate, he then attended Bryant University and then the National Defense University, where he received a master's degrees in business administration and national resource strategy, respectively. Tom went on to have a decorated career in the U.S. Air Force, retiring as Lieutenant General and earning multiple military service awards, including the Distinguished Service Medal, the Defense Superior Service Medal, and the Legion of Merit. Tom has also received the NRO Gold Medals, the General Bernard Schriever Award, and the Peter B. Tietz Award. He is an associate member or fellow of the AIAA, and I may add a very active and dedicated member. Thank you for that. And is currently serving, as we know, as the chair of the New Horizons Forum. So it's my pleasure to welcome Tom Sheridan to the podium. Tom? Thank you, Tom.
Well, good afternoon. Welcome to Texas. I want to make sure you're pumped and ready to go out there. And welcome to the Aerospace Sciences meeting for this year, and especially to the New Horizons Forum. Our theme this year for this forum is Aerospace Science. We push the envelope, we solve hard problems, we build the future. We've done this in aerospace for the last 100 years, and we've done this in space for more than 50 years. Our collective work has moved the world forward, helped us connect much more closely together, and allowed us to literally reach the stars. So what's to come next is up to us. Over the coming 4 days, we're going to hear about and discuss intelligence, surveillance, and reconnaissance, worldwide connectivity, movements toward autonomy and control and direction in aerospace assets, current efforts, progress and needs in research and development, information technology and its critical importance to our aerospace future, and systems engineering, the glue that successfully turns out our wildest dreams and pulls them together for the future. To kick off our program today, it gives me great pleasure to introduce our keynote speaker, Lieutenant General Larry James. General James serves as the Air Force Deputy Chief of Staff for Intelligence, Surveillance, and Reconnaissance at Headquarters, United States Air Force. He has a deep background in space development, in operations, and in space launch, in military and national intelligence, and in air operations. He's a distinguished grad of the United States Air Force Academy in astroengineering, and he earned his master's in astroengineering from MIT. Larry, the floor is yours.
Thanks, and to Tom and Sandy, thank you for allowing me to be here today to kick this off. It's a great opportunity to really explain to the broad audience here what's going on in Air Force intelligence, surveillance, and reconnaissance, and it's even bigger than Texas. So we look forward to at least helping you to understand where we are today, and really we're going to follow the themes of the conference, and that's how we push the envelope, how we solve hard problems, and how we build the future from an Air Force ISR perspective. So the first thing I would like to do is just kick it off with a short video that will give you a picture of the broad scope of Air Force intelligence, surveillance, and reconnaissance. So if you could start the video. So I hope that gave you at least a sense of the scope of Air Force intelligence, surveillance, and reconnaissance. It is broad, it is global, it is worldwide, it is strategic. It really cuts across all the domains as we define them: air, space, and cyber. Those are the domains that the Air Force operates in. So what I'd like to do is just start off by talking about really pushing the envelope. And I use the context of that in terms of what we have really done in these last 11 years as we've been executing operations in Iraq, in Afghanistan, conducting the counterterrorism mission across that battle space. Because frankly, we truly have changed the face of intelligence, surveillance, and reconnaissance for the Air Force, driven by those imperatives of that counterterrorism fight. If you look at the airborne capabilities we have brought to bear over the last 11 years, it really is pretty staggering. If you look at our manned airborne ISR platforms, we were flying about 5,000 hours per year of reconnaissance in those platforms in roughly 2001. Today, per year, we're flying about 93,000 hours per year in those manned ISR platforms. And of course, what most people think about when they think about airborne ISR is our Predator and Reaper programs, our Global Hawk programs. The newspaper likes to call them drones. We call them remotely piloted aircraft because there's a lot of people in the loop when you're operating these things. But we really started off, again, back in the 2001 time frame, about 4,800 hours per year. Last year, 2011, the last year we've compiled statistics, we flew 327,000 hours of unmanned airborne ISR. So just 4,000% increase in terms of the number of hours that we're actually flying these capabilities in support of operations around the globe. In terms of the number of platforms, we've increased those by 40-fold when you talk airborne ISR. In terms of the investment, we've gone from about a $700 million investment per year to $3.9 billion of investment per year. So again, I just wanted to give you a sense of the scope in terms of what the Air Force has been trying to accomplish from a broad strategic level capability in intelligence, surveillance, and reconnaissance. And in terms of pushing the envelope, if you look on this slide, I will just start up in the upper left, the MC-12. This was a platform that we actually put together in 8 months from inception to combat operations. And it's a multi-INT platform, it's electro-optical, it's IR, it's signals intelligence, It's the ability to put all that together, get it down to the ground, and inform the ground combatant commander or the folks that are doing the processing about what's going on in the battle space. Tremendously successful because we do day-night operations. We can merge that signals intelligence information with that electro-optical information to find targets, track targets, and go after targets. I had the opportunity a couple of visits ago in Afghanistan to actually fly missions over there with the crews that are there. And a tremendous capability that is in high demand in support of operations on the ground because it gives that overwatching eye for those combat operations that are going on. So just a tremendously successful program, really the fastest we've brought anything to bear in terms of providing capability since the P-51 in World War II. So a great success story in that. If you look at the lower left, something called Gorgon Stare. That is a sensor that we've brought to the fight that is what we call wide area motion imagery. Really the technology there was to take individual cameras and stitch them together so that we could provide what we call wide area motion imagery. It's about 2 frames per second, so it's not full motion video, but it allows us to go after that wide area surveillance in a persistent manner. So again, the teams are able to actually create the algorithms to allow us to stitch all this information together and currently give a 4 by 4 kilometer look at a location on the ground persistently. We fly it on a Predator, and so we can loiter for hours and hours over one location and just watch what's going on the ground. And then the next generation of that, Increment 2, will be deployed this spring, probably May or June, and that will give us an 8 kilometer by 8 kilometer view of what's going on. So to put that in context here, that's about 2/3 the size of Grapevine, Texas, that we could have a persistent, overwatching eye that can do all the intelligence in terms of tracking vehicles, tracking people, tracking movement, and just seeing the battle space persistently with enough fidelity to actually do intelligence. So we've pushed that out to the fight. If you think about some of the other capabilities we've pushed out to the fight, that system you see in the center, Distributed Common Ground System, that really is the heart and soul of Air Force ISR, because you can push sensors into the air, you can push platforms into the air, you can create data, but it really is meaningless unless you have something that is processing that data and something that is turning that data into knowledge that decision makers can use. And that's what that Distributed Common Ground System is all about. And again, we truly have pushed the envelope in terms of its capabilities over the last 11 years. If you go back to its inception, it really was created as a system that would take U2 data and process that data and create intelligence and get that out to the commanders. Since then, and that was, if you go back to about '94, we deployed it to support operations in Haiti, and that's really all it could do. Today, it really is a multi-int platform. It brings in multiple sources of intelligence. It processes data from the U2, from the Rivet Joint Signals Intelligence Platform, from the Predators, from the Reapers, from the MC-12s, from the Gorgon Stare, as well as reaching out and accessing other databases such as electro-optical, signals intelligence, and puts all of that together in order to create information that is of decision quality. So from that small transportable capability we had back in the mid-90s, today we have a worldwide system. It consists of 5 primary nodes in Virginia, in California, in Hawaii, in Korea, and in Germany. It consists of 50 other associated nodes that allow us to basically move this information around the globe and process that information as we need to process in order to support combat operations or any other operations. So a great example, you go back almost 2 years ago into the time that really March of 2011 and what we call March Madness, when we were conducting operations in Iraq and Afghanistan, and then we had the operations that kicked off in Libya, and then we had the tsunami in Japan. All this happening over really about a 3 to 4 week period. The Libya operation wasn't really planned. It came about very suddenly. Obviously, the tsunami was something that surprised all of us. And yet, with that Distributed Common Ground System, we were able to put platforms in the air. We were able to support the operations in Iraq and Afghanistan. We were able to support the operations in Libya, as well as support humanitarian relief and disaster assistance in Japan at each of those nodes. And we could move the information to Hawaii, or we could move the information to Germany, or wherever we needed to move it in order to do the processing and make use of the skill sets that are at those various ground nodes. So again, pushing that envelope from a very small deployable platform back in the mid-90s to this worldwide strategic capability that we have today is something that really has driven Air Force ISR and our capabilities, because again, without that PED, without that processing, exploitation, and dissemination at the end of the chain, none of these sensors do you any good. So that's just a quick picture of what we have done over the last decade or so, whether it's in platforms, whether it's in sensors, whether it's in ground processing, to really drive our capabilities as an Air Force and as a nation to allow us to get at these very difficult intelligence problems that we've been going after over the last decade. Next slide. So, solving hard problems. And I think, we'll reflect on what I just talked about, but with a little more specificity on some of the issues that we've tried to deal with from a solving hard problems perspective. One of those hard problems is multi-int fusion. In the Cold War, we would do things like take overhead pictures, electro-optical images, we would count tanks, we would look at ICBMs, kind of a pretty narrow focus, if you will, relying on EO capabilities, et cetera. But really the coin of the realm today is that multi-intelligence, that multi-int capability, where you bring in all of these different sources of information and create knowledge and information out of that. So one of the things that we have done as we've conducted operations in Afghanistan and Iraq is create a platform called the Blue Devil. And its power is just that, its ability to take these disparate sources of information and actually fuse them on board the aircraft, and then in near real time provide that fused product to a ground commander, to a command and control node, whoever needs it, so that we can take that signals intelligence view, we can take that electro-optical or IR view, we can take that full motion video view, that wide area motion imagery view, take all that into this platform that is airborne, and in near real time put that together in a meaningful manner and push processed information that gives knowledge to the ground force commander or the combatant commander about what's going on in his battle space. Easier said than done to put all this together in a meaningful fashion, and yet the team from Air Force Research Lab has done a great job with that Blue Devil program and putting that together. So in fact, it is very high priority. It has been asked to stay in theater through the end of combat operations. So we will continue to provide that support to the combatant commander in Afghanistan. If you look at some of the sensors, I mentioned the Gorgon Stare. We also have something called ACES High. Again, getting at that hard problem of concealment and deception, that hard problem of homemade explosives, that hard problem of improvised explosive devices. And one of the ways we tried to get at that was with a hyperspectral imager, an HSI sensor, that comprises the heart and soul of that ACES High platform. So again, building that capability to go across that spectrum, that hyperspectral image spectrum, and try to find particular things that we are looking for, whether they're concealed, whether they're of a particular chemical compound, whatever the case may be. That was the problem that we were trying to get after. And so we actually deployed ACES High about 8 months ago in Afghanistan, flying it as 2 pods on a Reaper in the battle space, and again being very successful, doing very good work in terms of very few false positives in terms of what it's detecting, and providing key information that then triggers other people to go after different problems. And I can't go into a lot of details on the specifics, but let me just say that from a hyperspectral imagery perspective, this has been very successful, and a lot of that is just smart people getting the right algorithms built, understanding how I take this information, what am I actually looking for, how do I tweak it and get it right so that I'm not, again, giving off false positives and sending people into harm's way when there's really nothing there, those sorts of things. So very successful, been deployed less than a year, and yet making a tremendous difference in the battle space in terms of HSI capability. You see the satellite there, SBIRS, Space-Based Infrared System. And I'll kind of touch on this a little later in terms of our capabilities from space. But obviously, we launched SBIRS HEO a few years ago, the highly elliptical orbit systems, a couple of those currently flying. We now have SBIRS GEO in orbit, going through its initial checkouts and validation. But OPIR, overhead persistent infrared, we are finding is a very powerful tool that gives us persistence in the battle space and allows us to see a lot of things in the infrared world that frankly we haven't been able to see in the past with these very high quality sensors that SBIRS provides us. So really, we really are, in my mind, in the cutting edge right now of understanding what we can do with this information. NASIC, the National Air and Space Intelligence Center out at Wright-Patterson Air Force Base, Ohio, is really kind of leading the charge for the nation, in my opinion, on OPIR. And just recently, in fact, back in November, we did the first exercise where we took OPIR data, fed it into that distributed common ground system, and started to really work through in an exercise mode. What can we do with this data? How can we overlay this data on other products? What can we see with this data? Is it meaningful intelligence value? How good is it? Those type of questions that we're asking ourselves. And this is hard work because, I mean, you're talking about things that are sometimes very down in the signal to noise limits and those sorts of things. And so pulling that data out is not necessarily easy when you talk about very dim IR targets. And yet the folks at NASIC are doing tremendous work in being able to do that. Now, it's a step to go from kind of the very intensive time, takes a lot of time to sometimes pull this information out, to getting that to a near real-time capability that you would like in the intelligence domain. But again, a lot of good work going on there in terms of bringing that type of capability into that intelligence machine that is DCGS that would allow us to go after hard problems. So that's just, again, some of the work that's been going on that allows us to start to get after some of these hard problems that we've been given, whether it's to support operations in the current fight, or whether it's to think about how we support operations in the future. So next slide. And that kind of segues right into that question about the future. And you see the little bumper sticker there, all sources, all domains. If you think about how we've been operating over the last 10, 11 years from a ISR perspective, from an Air Force perspective, we really have been operating in a very airborne permissive environment. We have had no threat that we have had to deal with in terms of flying all of our airborne sensors, whether that's Global Hawk, whether that's Predators and Reapers, whatever the case may be. We can fly those with impunity. We can fly those wherever we want over Afghanistan, over Iraq, and accomplish that mission. But as you've looked at the new strategy for the United States, which talks about rebalancing toward the Pacific, as it talks about what we call anti-access area denial environments, where that airspace will be contested, that airspace will be non-permissive, that airspace will be harder to get into. That's a whole different problem that we as a nation and that we in the Air Force have to think about. So the Secretary of the Air Force about a year and a half ago said we need to start thinking about, as an Air Force, how do we get after that problem from an intelligence, surveillance, and reconnaissance perspective. Because all the things we learned, all the expectations we've had about that really unblinking eye over the battle space could go away. In fact, we had our senior ISR officers conference a couple of months ago, and we had a briefing from Afghanistan, and they laid out a whole PowerPoint slide with a font about that big of every airborne ISR sensor they had operating in the battle space. And so my question to the folks there was, now what do you do when you have none of that? Because it's a contested environment. And so that's why we get to that bumper sticker of all sources and all domains, because the next conflict, the next fight that we may be in, probably we're not going to have that air superiority right away over the entire battle space. So how do we start to think about operations in that domain? How do we start to think about what capabilities we have to have in order to operate in that domain? And so as we went through that tasking from the Secretary and really did about a 6-month look, utilizing industry, utilizing a lot of the labs, utilizing a lot of people to say, what do we have to do to get at that? A couple of key things. Number one was the network architecture. You heard me talk about moving all this data around between the DCGS sites when we were doing operations in Libya and Japan and Iraq and Afghanistan. That relies on a network to move that data around. We rely on a network to get the data from the platforms, from the sensors, into the processing nodes, out to the user, and all of those things. And I will guarantee you that those networks will be contested in the future. So the question is, how do we build a robust network that can operate in that type of environment? And then how do we build a network that will have the capacity to handle all of this data? I talked about Gorgon Stair. If you look at the next generation of that system, it's a system called Argus. It will produce the equivalent of 85 years of high-definition video movies every day, one sensor. Now you multiply that by X number of sensors operating over X number of days, and obviously you see some of the problems. Today, DCGS processes 20 terabytes of information a day. And that's only going to grow. So how do I create these networks that allow me to handle that much information? You know, many of you, we call it the big data problem. We're doing a lot of work with industry on that. We've got some pilot programs we're working with DISA in terms of how do you handle that scale of data, especially large data objects and those sorts of things that we're dealing with. So that whole network question, I think, is one of the future problems that this community certainly is going to have to help us solve. What is that architecture? In fact, we're going to be briefing the Secretary this week. One of the tasks he gave us was help to define that architecture. So one of the briefings we're going to be giving him this week is kind of what we see that to-be architecture should look like. And frankly, we're not there yet because it's very complex, it's very demanding, and you throw in, again, the contested environment side of this thing, and that makes it even harder. But we're getting at that problem. Another problem is the tools that allow us to do something with the data, the analytics that allow us to do something with that data. You heard me talk about, for example, that Blue Devil airborne platform where we bring all the data in, we fuse it together, and we do good things with it. But when you multiply that by 1,000 or whatever the case may be in terms of the sources of data and in terms of the types of data, again, the human can't be the limiting factor here. If you go into a DCGS site today, you'll find that generally there's a non-commissioned officer staring at a screen that has a Predator or Reaper feed, a full motion video that's overlooking a compound in Afghanistan, and he's watching or developing pattern of life, or he's supporting a task force operation or whatever the case may be. But he may be sitting there on an 8-hour shift, he'll sit for an hour, somebody will replace him, he'll take a break, he'll come back, staring at video. And I would offer that as a lousy way to use the human brain. Now you multiply that by all the different sources of information we're going to continue to feed into DCGS, whether that's, again, EO, IR, LIDAR, HSI, SIGINT, HUMINT, open source, whatever the case may be, the machines absolutely have to help us take that data, make sense of that data, fuse that data together, find that data, and ultimately give the human something that it makes sense for the human to be doing in terms of the gray matter between his ears. So those processes are important, and then the tools that go along with that, whether it's full motion video tools that can track an object, whether it's signals intelligence tools that can pull out the right piece of information, whether it's change detection tools that allow us to understand what has changed between one look and another look. There's a whole host of demands out there in terms of the tool sets that we are going to need to handle this much information. And again, industry is looking at this. A lot of good things going on there. In fact, CNN did a little piece on what we're doing with DCGS because we've sent people up to ESPN, we've sent people up to CNN, we've sent people up to, who else did we send them to? Anyway, people that are handling large quantities of data and what do they do with it and how they process it. Of course, the attention step that they did in the little piece they did on CNN was how they do Honey Boo Boo and how they do the Kardashians. So, you know, that was not a good thing. But bottom line is that we have to have the tool sets and the analytics to handle all this data. And then the third thing is really that all source, all domain. I talked a lot about that, what I would call the airborne layer of ISR that we've really come to rely on, depend on in terms of current operations, all the things we have flying in the air. But then I pointed out that in a contested environment, many of those things may not be flying. So how do we get at that problem, that anti-access area denial problem? Certainly, I think, first of all, it's going back to our roots, and that's thinking about every source of information that we can get our fingers on. You go back to the Cold War, it was largely what we call national technical means, but really overhead satellite capability that was monitoring the Soviet Union. And so that space layer is going to become more important in the future, in my opinion. The airborne layer may still be there, and I'll talk a little bit about that in a minute. And then there's the cyber layer as a source of information. But there's also human intelligence. There's also open source intelligence. You see a lot of people now talking about, even industry, what can I glean from Twitter? You can even buy a service from Twitter that says, they'll tell you what's trending and what's important and what are people focused on. That is a source of intelligence, obviously. So how do we start to bring all of that together across all of these problems that we will be dealing with and understanding what's going on? I mean, I would almost guarantee you that any major event that happens today around the world, the first thing we're going to see is an iPhone photo posted on the internet that tells us about it. That is a source of intelligence. And so we as an intelligence community are going to have to figure out, how do you harvest all of that information in order to get at the problems that we've been given? So that all sources, all domains, very important. Now the airborne layer, I mean, we're looking at those sorts of things. We have a lot of work going on in what we have in the past called non-traditional ISR capabilities. One of those would be, for example, the F-22 and the F-35 penetrating platforms, so they can go into those high-threat environments and survive, but they are tremendous sensor platforms. If you look at the sensors that we have on an F-35, it really is a flying software machine with sensors on it, is what it is. Almost 10 million lines of code on that thing. And so making use of the SAR radar, making use of the ELINT and SIGINT capabilities, the EO capabilities, the IR capabilities, not for executing the attack or executing the defense, which is important, obviously that's their primary mission, but how do I also get that data out for ISR purposes, for intelligence purposes, because that may be the only thing that's flying in that battle space. So that's something that we're working on. And in fact, just met with Lockheed Martin folks to talk about that this morning before I came over here. Another thing is standoff. If I can't stand the threat near in, what can I do from a standoff distance? If I've got a U-2 that's flying above 50,000 feet, what kind of sensor can I put on that thing that will allow me to see well into the battle space? I stay out of the threat ring, and yet this sensor can see very clearly down to, 10 centimeters, 20 centimeters, whatever the case may be, so I can actually glean intelligence against those hard problem sets at a standoff distance. So sensors may be one of our solution sets as we think about operations in an anti-access environment. And then cyber. I think that is going to be a tremendous source of intelligence. I think obviously we have to mine that. We have to sort out, how do we get to those sources of information? How do we bring that information into the DCGS? How do you assure it's valid information? All those kind of questions that you have to answer. But all of that has to be a part of the trade space as we think about this very difficult problem that we're trying to get at. And then lastly, we're not going to do this alone. We're going to be operating as a coalition. We're going to be fighting as a coalition. And so how do we ensure that they have the capabilities that they need to stay up with us? And how do we take advantage of what they're doing in order to help support the operations that we're conducting together? I was over in England about 3 weeks ago, and they're actually buying our signals intelligence aircraft, the Rivet Joint, for the UK. So they're going to have 3 RJ-135 aircraft that they're actually going to fly and actually make a part of the U.S. command and control system so that they can be assigned to support our worldwide missions. That's just one example of what's going on in that world. They're also buying Reaper drones, remotely piloted aircraft, and so making that a part of that worldwide strategic infrastructure for ISR is something that they've committed to do as well. So helping to leverage our allies, whether it's UK, Australia, the Five Eyes as we call them, other key allies. You may have read in the news this week that South Korea is looking to buy Global Hawks. So we're just in the middle of that in terms of helping them to get that capability. Obviously a lot to do in terms of foreign sales and those sorts of things, but they ideally would have that capability in a Korea scenario or a South China Sea scenario that we could leverage. So helping those allies make sure they're up on the technological step, equal with us, and then making sure that we can integrate all of this together from an allied perspective will be very important. Next slide. So at the end of the day, really what we're all about is delivering decision advantage. As I said, it doesn't matter how many sensors, how many platforms, how many sources of information. Until you can do something with all that information to deliver that decision advantage, it's useless. So that is really, from an Air Force ISR perspective, what we're all about. I would offer that I think we set that gold standard from the Department of Defense for that worldwide view, that strategic capability, looking all across the battle space, not just at particular Air Force problem sets, but really have the capability to look globally and execute missions globally. We indeed do set the gold standard, in my opinion. And our mantra, kind of as you see there at the bottom left, the right information to the right people at the right time, ultimately to make the right decision. So that's just a quick overview of kind of where we've been, some of the hard problems we've had to overcome, and what we're thinking about for the future. And I hope that gives you a good sense of your overall Air Force ISR capabilities. And I'd be happy to take some questions. I know that a bunch of engineers and scientists will have to be questions out there. I got one back there. Not really, in terms of an ISR perspective. I don't know that we have to go super hypersonic to really execute that ISR mission. Certainly, as you think, as I said, about the F-22 and the F-35, they're supersonic platforms, and we do indeed need to give them the capacity to be an ISR platform more than they are today. But there's really nothing on the books that says we need to go after a high altitude, very fast capability. Certainly high altitude is important. You look at the Global Hawk, high altitude capability, the Block 40, we're going to be bringing that on actually this spring, which is a SAR and a GMTI, ground moving target indicator platform operating at high altitude. The whole question of high altitude extended range or high altitude long endurance capability is something that we're looking at in terms of the ability to operate very high and stay there for long periods of time, up to days, and do an ISR mission we think can be valuable. So in that sense, there's work going on, but the high-speed piece is, other than exercising with the F-22 and F-35, nothing really out there that we're looking at. Sure. Yes, Sandy. We certainly continue to look at sensors. I didn't mention LiDAR, for example, light imaging and detection and ranging. So that's one example where we said, what can we do with laser sensors? For example, in Afghanistan, we deployed a couple of systems over there. One that we use for wide area mapping down to about, I think, 20 centimeters of accuracy, because frankly, we had lousy maps of Afghanistan. So if you want a very precise map of what's going on, even better than detailed quality, we found out we could do that with these LiDAR sensors. And now AFRL is kind of trying to take that to the next step in terms of how do I extend the range of those things. So yes, we're certainly interested in enhancing things like LiDAR, improving some of the FMV so it's high definition, improving the wide area motion imagery, improving IR. We work a lot with Lincoln Labs up at MIT on a lot of these sensor suite capabilities and how do we take them to the next level in terms of sensitivity or field of view or whatever, or how we process, whatever the case may be. I can't speak real well to how you integrate that with aviation. There's certain things, for example, on the F-35 and F-22 that are sensors that are very capable. but I don't honestly know what are the connections between, for example, the civil aviation world, but certainly the military aviation world. I think there is a lot of synergy between, for example, military aviation sensor requirements, because a lot of it, let's take IR, a lot of it is just about, how we build a focal plane. Is it, 4K by 4K or 1K by 1K? How do we stitch it all together? It's kind of the same problem sets. How much sensitivity do you want? And those then can have applicability to a broad variety of problems, whether it's aviation, whether it's ISR, whether it's space. Yes? I had touched intelligence, and there were a lot of different ways. And 3 assignments before this one, I was the director of signals intelligence at the NRO. So, yes, some. I'm not a career intel guy, but a lot of this is very similar to some of the other problem sets that we face. Sometimes it's just about how do you put all these systems together. And I would offer, just kind of an aside comment, but you read articles in the paper about other people developing drones, remotely piloted aircraft. And frankly, there are a lot of people out there developing those types of systems. But the power, I think, that the U.S. and this community brings is the ability to really put all of this stuff together. I mean, it's one thing to build a remotely piloted aircraft, and yeah, I can fly it, and yeah, I can put a camera on it, I can look down. But really, the power that we have is the ability to put multi-types of sensors together, the ability to do the systems engineering to bring all of this together, the ability then to process all that information and make sense out of it. I would offer that there really is no one today that comes close in the ability to put all this together. And frankly, that's where this community needs to keep us well ahead of any other competing nation in that arena. The ability to make sense of all of this, bring all of these systems together in a cohesive fashion to produce something that's meaningful and useful for our decision makers. And that really is the power, I think, of what we can do. No one else has the worldwide capability. No one else, in my opinion, has the ability to really bring all of this information together and make it coherent, if you will, and meaningful. But that's our leading edge, in my opinion, and this community has to help us stay there. Yes? Sure. Just, kind of at the personal level, the head of Army Intelligence, General Mary Legere, we work very closely together. We're even having dialogue about taking Army exploiters of information and intelligence and putting them in Air Force sites when they're not deployed. So we very much are in tune. We get together about once a month, the Air Force, the Army, and the Marine Corps, and the Navy intel chiefs, and just talk about what we are doing and how we can work better together. So on a personal level, I think that's going very well. But the other side of that is that at the end of the day, all we really care about from an intelligence perspective is the data. So if the Army DCGS system, and there is an Army DCGS system, has data that helps us solve a problem that we have, we need the ability to reach into that data. That data needs to be all formatted the same so our systems can operate on it, and we can pull it into our system and utilize it as we need to solve the problem we've been given. Same for the Army reaching into the Air Force data. Same for the Air Force reaching into the NSA data or the National Geospatial Intelligence Agency data, NGA. So the whole community across the intelligence world, really at the direction of Director Clapper, is indeed pushing toward this integrated concept where we can access each other's data. The machines then have to help us know where to go and pull the right data in, because we're all going to be going after different problems in many instances. For example, the Air Force is probably going to be very concerned about the integrated air defense system, and so we'll want all the data that there is out there on that, whether that's Navy data, NRO data, CIA data, it doesn't matter, but we have to have the ability to access all those databases pull that information in and then operate on it. So it's more a matter of making sure that, there's not a lot of overlap, and because in austere budget times we don't want that. And that's part of what the DNI is doing, the Director of National Intelligence. Making sure all the data is formatted correctly so we can all operate on it in the same way. Making sure the data is tagged properly so we can go out and find what we need. And then making sure the machines have the ability to go out and pull all that stuff in. So that's really the vision that we have. And certainly we're working together, but it's not so much about, well, you created this and I created this. It's just about whatever we create, we make discoverable and accessible. Yes?
You talked about the 40 fold that increased the number of platforms.
Mm-hmm. I think that is something that we, as an Air Force, will be looking at, because we have to weigh what did we create for this permissive environment, how much of that do we need in the future, and then what do we need to invest in for a less permissive, non-permissive, or anti-access area denial environment. And those are trades, I think, that are going to be made in the 15 budget and out as we look to the future. We're going to have to retain capability to do these permissive operations, because I will bet that the counterterrorism mission is not going to go away. You see operations in Yemen, you see operations in Africa, you see operations all over that area. So we have to continue to provide those capabilities. At what level, I think, is something that we can talk about. And then those things that are more of a permissive environment capability, like the big jets, like the RC-135 or J-Stars or whatever, what can they do from a standoff distance? What can they do in a semi-permissive world that we may be called to operate in? So those are all trades that we're going to be looking at. But there's nothing right now where we say, okay, you did well in Afghanistan, but we don't need you anymore. We're going to get rid of it. The Blue Devil that I talked about, which is that multi-infusion platform, our intent is, once we're done in Afghanistan, to harvest that technology and look at how do we continue to integrate that capability on future platforms. So there will be trades as we look at it across the battle space, but I will tell you that, frankly, from the SEPGEF on down, ISR is very much supported, because people understand that we must have this intelligence, because as you have fewer and fewer forces, in my opinion, you need more and more intelligence. Because you don't have the capability to react as well as you would like, so you want to have that intelligence which allows you to head off the problems before they begin. But we'll certainly do the trades as we build the FY-15 POM this spring. But I don't anticipate major changes, frankly. Okay. Well, again, it's really been a privilege to be here today and help kick off a very important AIAA symposium. And Tom, again, thank you for the opportunity, and Sandy as well. Thanks.
So on behalf of AIAA, General James, thanks so much for coming and sharing your work and what the Air Force is doing in ISR today. A great start, I think, to a week of very exciting presentations. Let me present this to you on behalf of AIAA and say thanks so much.
Thank you, Tom. Appreciate it. Thank you.
Just a quick paid political announcement as you're walking out for the next